Welcome to the DIY Honda Garage channel. The trouble code P0A11-00 indicates a malfunction in the DC-DC converter activation circuit. This code is stored when the Powertrain Control Module, PCM, fails to receive a boost demand notification from the DC-DC converter, suggesting an issue with communication between components. The PCM is essentially the vehicle's computer that monitors and controls engine performance, including how electricity is distributed within the car. The DC-DC converter plays a crucial role in converting high-voltage battery power to lower voltages used by the vehicle's electrical systems and auxiliaries. If there's a failure in the signal communication between these components, it can lead to performance issues or even vehicle shutdown. This diagnostic code should prompt a thorough inspection of the DC-DC converter, the PCM, and their respective wiring circuits to pinpoint and resolve the issue effectively. The DC-DC converter is responsible for maintaining electrical power supply from the vehicle's high-voltage battery to low-voltage systems. It ensures that components like lights, infotainment, and climate control function appropriately. The Powertrain Control Module, PCM, monitors the performance of the vehicle and coordinates with the DC-DC converter by sending boost demand requests. The PCM is typically located near the engine, while the DC-DC converter is often situated in the vicinity of the high-voltage battery. When the PCM cannot receive notifications about power demands, it determines that there is an abnormality in the system, leading to the storage of DTC P0A11-00. This failure mechanism is significant as it indicates potential underlying problems in electrical communication or component functionality, which need to be addressed promptly. Various issues can lead to DTC P0A11 being triggered. First, an open circuit in the DC-STS, DC-DC status, can disrupt communication, preventing the PCM from receiving necessary signals. A short circuit in the DC-STS could also produce incorrect voltage readings, leading to miscommunication. Additionally, a malfunctioning DC-DC converter may be unable to send out the boost demand notifications at all, which directly affects the PCM's operation. Lastly, if all other components check out, then the PCM itself could be faulty, indicating that the vehicle's central control system needs to be examined for issues. It's crucial to methodically inspect these components, as each one plays a pivotal role in the overall functionality of the vehicle's electrical system. The symptoms associated with DTC P0A11 can be quite significant, affecting the overall performance of the vehicle. Drivers may experience engine performance issues, such as stalling or reduced acceleration, as the vehicle's electrical supply is disrupted. Additionally, a failure or malfunction in the battery system may arise, leading to battery charge issues, which can prevent the vehicle from starting or cause it to shut down unexpectedly. Electrical system failures can also manifest, affecting areas like lighting, displays, and other electronic accessories within the vehicle. These symptoms typically indicate that there is greater complexity within the electrical circuits, and that immediate diagnostic actions are crucial in preventing further operational failures. The first step in troubleshooting DTC P0A11 involves conducting a test drive of the vehicle. This helps to assess whether the vehicle exhibits any abnormal driving behavior that could be associated with the DTC. After performing the test drive, the engine should be stopped using the auto idle stop feature. This function is designed to reduce fuel consumption and emissions, and stopping the engine in this manner may also help to reset various systems for diagnostics. This initial diagnostic provides insights into the vehicle's operational status and is critical in developing a strategy for further investigation into the electrical components involved. The next step is to inspect the DC_STS DC status circuit. This circuit is crucial because it handles the communication between the DC-DC converter and the PCM. It is important to check for open circuits, which can prevent signals from transmitting correctly. This can often be done by using a multimeter to measure resistance across the circuit connections. Under normal conditions, the resistance should be below 1 ohm. If there is a fault detected within the DC_STS circuit, it will indicate that an underlying wiring issue or connection failure exists, necessitating a more thorough examination. Following the inspection of open circuits, the next troubleshooting step involves checking for a short-to-power condition in the DC-STC circuit. This condition can cause the circuit to send false signals to the PCM, leading to erroneous readings or failure notifications. This inspection would typically require disconnecting the connectors and using diagnostic tools to measure the circuit's voltage levels while the system is powered. It's essential to ensure that none of the terminals are shorted to the battery voltage inadvertently. If shorting is detected, the wiring and connectors should be evaluated for any signs of damage or wear that could compromise circuit integrity. At this stage, the focus shifts to inspecting the DC-DC converter itself. There's no direct method to test its functionality. The most effective approach is to invest in a known good, already verified functional DC-DC converter. This replacement allows for a comparative assessment. If the issue persists or the DTC remains active with the new component, then it can be inferred that the problem might lie with the PCM or other connected components. Alternatively, if the DTC is cleared and the vehicle operates normally, this confirms that the original DC-DC converter was the source of the malfunction, requiring its replacement. If the DC-DC converter tests clear or replaces without resolution of the DTC, the focus turns to the PCM. Since it's the final piece in the signal chain, it's vital to examine this component last, after all else has been ruled out. This inspection typically involves verifying that all related items are functioning normally and confirm their properties. The PCM must be thoroughly checked for any internal faults or programming issues that may prevent it from processing signals correctly. If indeed the PCM is faulty, it will require replacement or reprogramming to restore proper functionality and clear the stored DTC. After completing all repairs and component replacements, it's essential to proceed with final verification to ensure that the issues have been fully resolved. This starts by starting the vehicle and observing its performance. During this test, the PCM should be monitored for any repeated triggers of DTC P0A11-00. If the DTC does not return and all systems operate normally, this confirms that the repair was successful and no additional issues are present. The final check ensures that the vehicle is safe to drive and properly functional, minimizing the chance of similar problems arising in the near future and validating the effectiveness of performed repairs. To avoid future occurrences of DTC P0A11-00 and to ensure the long-term functionality of the vehicle, it is crucial to implement regular preventive maintenance. This includes periodic inspections of the vehicle's electrical systems, particularly focusing on connections, wiring integrity, and component functionality. Keeping the connectors and wires clean and free of corrosion will help maintain communication efficiency between the PCM and the DC-DC converter. Additionally, monitoring the overall condition of the DC-DC converter and the PCM can help preemptively identify any signs of wear or malfunction. Proper maintenance actions can significantly reduce the likelihood of malfunctions, ensuring a reliable and efficient vehicle performance. In summary, DTC P0A11-00 signifies a malfunction within the DC-DC converter activation circuit, often due to communication failures between the PCM and the DC-DC converter. It is essential to understand both the role of the components involved, as well as the thorough troubleshooting steps required to accurately diagnose the issue. Regular maintenance and vigilant inspections are important in preventing this code from triggering. Each component's functionality should be verified in a systematic manner, ensuring all potential fault sources are addressed. Ultimately, effective diagnosis and repair will enhance vehicle performance, assure driver safety, and prolong the life of the electrical systems. Please like and subscribe to the channel. See you next time.